It's my great pleasure to be back here at this conference. This is my either fourth or fifth time speaking at this particular conference. And today I'm going to speak to you about 3D printing. And this topic is the most exciting topic that I have talked about, I think, in my almost 30 years of practicing law, giving hundreds of speeches in different places in the world. I could talk about it all day. And for that reason, I also have a cell phone here, because I don't wear a watch. Robin, you and I belong in this program, because neither one of us can keep track of the time. And as my wife can tell you, I could talk about this topic all day long, all week, and I could bore you with it eventually. But I'm going to try to keep it down to 45 minutes. How many people here know anything about 3D printing? 3D printing. Okay, all right. Well, you're going to learn a lot about it as we go through this program. But I want to start with a couple of things that you should keep in mind. One is that it's going to change everything. Two, you can make anything. It's about to become mainstream. It's been done in this country. It's been done all over the world really since about the 1980s. But it's about to become mainstream. It's about to come into your homes. Up until now, it's been done on an industrial level. It's still pretty primitive in some areas. The home 3D printers that you'll hear about, they're still fairly primitive, but it's about to become mainstream. It's about to come into your home. What I'd like you to do as you listen to this presentation is think about how it could affect your life. What things in your life might be 3D printed in the short term and the long term. Think about how it will affect your practices. Think about how it will affect businesses in your area. Think about how it will affect the world. I think what you'll see as we go through this is that it will change. It has the potential to change everything. What is 3D printing? 3D printing is an additive process. Traditional manufacturing process has been subtractive. You take a piece of metal, for example, and you machine it, you drill it, you weld it, you do various things to it, and what's left after you start is less material than you started off with. 3D printing is exactly the opposite. It's an additive process. You take material and you lay it down a little bit at a time and you build up something. We have an illustration here at the bottom of the screen of a propeller. It shows where you start with nothing, you end up with a propeller at the end. We're going to see how that happens. The printing comes from a CAD design that's created either from a computer or from a 3D scanner. So from a computer, you design the product yourself. Whatever it happens to be, you design it. Then you print it. With a scanner, you take an existing product and you scan it on a 3D basis, and then you print it. Happens in one of two ways now. Either a type of material is melted and extruded a little bit at a time, or there's something called, and that's called additive fabrication, or 3D printing. It's kind of the umbrella term. Or a bed of powder is laid down, and then it's fused together. And that's called fused deposition modeling. Usually, after you have printed whatever it is that you're going to print, there's some kind of post-production work that's required. You either have to sand it, you have to polish it, you might need to sinter it, heat treat it in some way to make it stronger. Sometimes there are support structures because you can 3D print on a very fine, very small level with very thin walls. And you might need to hold it together. It might need to be supported while it's being printed, so you might have to remove those support structures. These are the ways that it's being done now. There is a company in Japan, Matsura Machinery, who has come up with a hybrid process where they print and they do high-speed milling at the same time to come up with an end product. Video, can we have a video, please? Now this is a 3D printer in action. It's a home 3D printer. You can see as it builds up this, it's a cup that you can have very thin walls. You can have a structure which is the handle, which doesn't need to be attached. It doesn't need to be welded or glued on. It's just part of the structure. The video is not working quite right, but there it goes. There it goes. So imagine if you can take this type of a device, this type of a product now, and you can do it yourself. You no longer have to buy a product like this. You can design it yourself, you can 3D scan it yourself, and then you can print it yourself. And there's the finished product. What materials are used right now for 3D printing? Mostly ABS plastic and PLA plastic, but there are also some companies, and if you buy one to do at home, it will be plastic. There are also some companies that make 3D printers that print in metal, and there's a growing body of materials that are being used to print ceramics, food, glass, and human tissue. We're going to talk about human tissue. It's just amazing. There's University of Exeter that has modified a 3D printer to print something really important, that's chocolate. You can print out all your Valentine's Day chocolate yourself, whatever format you want. But there's a lot of other exciting stuff going on. The Washington State University has created a bone-like material that provides support for bone growth. The University of Glasgow is printing organic compounds that are expected to be used in medicine delivery, so you'll be able to print your medicine. Think about what that will do to pharmaceutical companies. Think how they'll have to change to survive. University of Illinois Research Group is printing materials in very, very small sizes. And there are other organizations that are doing this as well. And for some reason, Cornell University decided to print little space shuttles using ground scallops and cheese. Don't ask me why. Soon, there are going to be materials that never existed before, hybrid materials. Right now, the printers mainly they'll use a plastic that exists. They'll use glass. They will use metals that exist. But researchers are working on hybrid materials that will have properties that combine the physical and electrical properties of existing materials, and they'll do things that nothing has done before. And then there will also be the ability to do multiple materials in the same run. So you saw that cup being made. That cup was made with ABS plastic. Well, what if you wanted to print a tennis racket? You'd have to be able to print with multiple materials at the same time. Let's say you want to print one of these. You have to be able to print multiple materials in the same run. So there's research being done that will allow materials to be manipulated on the atomic and molecular level, so the input material is whatever it happens to be, and the output material is whatever is needed during the printing process. There will also have to be developments made in terms of strength and durability. Right now, one of my partners, who's a materials scientist, says that it's never going to work. If you want to have, say, a bracket to hold a wing onto an airplane, and then you're going to get on this airplane and fly it somewhere, you want to make sure that it's strong. And he says it'll never happen, because if you're just printing something out, depositing this material, as I said, either extruding it or you're doing the fused deposition modeling, it'll never be strong enough. Well, I said to him, that's a temporary problem. Do you think that problem won't be solved? You're not being very practical. MIT is making large polyurethane forms that they will fill with concrete, used in the construction process. And a company called Contour Crafting is making low-cost emergency homes that are about 800 square meters, but you do have to buy the family separately. Right? Then there are the inks. Now in general sense, all of the material that's being used in a 3D printer is called an ink. But there are very specialized inks that are being developed. I've listed some here. The ones that I find very interesting are, for example, the fugitive inks and the polyelectrolyte inks, which will enable you to create self-healing materials that will allow for tissue engineering. And then there's the silver nanoparticle inks, where you'll be able to have wearable electronics. So imagine, I don't know about you and your cell phones, but I don't have very good, this thing is great for managing my life, but it's not a very good phone, right? Imagine if your jacket was an antenna, and that antenna is communicating wirelessly with your phone. Imagine the quality of the telephone call that you'd have if you'd be wearing your antenna. So printing things with the nanoparticle inks is just fascinating stuff. 3D printing today is mostly the creation of prototypes. About 70% of the market is to use 3D printers for rapid prototyping. I've been told that Ford Motor Company, every designer there has a 3D printer on his or her desk. And it enables you to make prototypes very quickly. If you design them on the screen, and then when you're ready, you print it out. If there's something wrong with it, you can change it a little bit. You can tweak it if it's not quite right. If you just want to make one, it doesn't cost anything more than making 10. And you can save cost by making these changes very quickly. And then the final product is probably closer to what you want it to be, because you've been able to tweak it as you go along, print it out as you go, until you get what you want. But where we're heading is direct digital manufacturing. This is where you will be able to make things in your house, or maybe you will use a service that's in your neighborhood, print something out for you. Or there will be companies who will 3D print things instead of manufacturing them the way they always did. And this is very important, because I've sat here since the beginning of this conference and I've heard how manufacturing has been leaving Australia. I didn't really know that until I came here. I haven't been here for several years. Last time I was here a few years ago, I didn't hear any of that. But in the United States, of course, we've been hearing that since after the Second World War, manufacturing leaving America. But for countries with high intellectual capital, but high manufacturing costs, high labor costs, this is a way to keep jobs in your country or repatriate those jobs. Because you no longer have to have things manufactured in a place where there's low-cost labor, like China, and then have them shipped to places where they're needed. Instead, you manufacture them where they are needed. There's no advantage to offshoring if you can 3D print. Now, I'll give you some examples. In aerospace, Boeing has this ducting system that's in the 787, and it could be made up of 20 parts, I suppose, maybe when they started designing that plane, which was, I think, sometime in the 1800s, I think is when they started designing the 787. At that time, it had 20 parts, but they are now 3D printing it in one piece. That, of course, saves on inventory, it saves on materials, it makes inspections better, there's less problems with it, and it weighs less, and weighing less translates into less fuel, and makes your airplane ticket a little bit less expensive. But there are 22,000 parts that Boeing is 3D printing, rather than having them made by someone else. Maybe someone is 3D printing them for Boeing, but the point is, rather than using traditional manufacturing processes, they're 3D printing them. And they're working on printing an entire wing. Haven't gotten there yet, but they're working on it. And Airbus, this is the example I gave you before about the wing bracket. Airbus is trying to perfect this wing bracket that you see on the screen. Actually, there are two wing brackets there. There's one in the foreground and there's one in the background. The one in the background is a traditionally manufactured wing bracket. It involves, I think, about 12 manufacturing steps. The one in the foreground requires one step. And it can be manufactured with parameters that you can't do if you were going to manufacture it in a traditional way. You can print it, you can print things in ways that is impossible to do traditionally. There's a company called Farah Engineering, which is here in Australia somewhere, and they are 3D printing titanium parts for the F-35 fighter. And 3D printing of titanium is very promising because, as everyone knows, titanium is very strong, it's very lightweight, and using powdered titanium gets over, and then 3D printing it, gets over some problems that traditionally have plagued manufacturing with titanium, such as welding. It's very hard to weld titanium and get it right. You get around that by 3D printing. And Farah Engineering is doing that for the F-35 fighter. 3D printing in outer space. NASA has over 70 3D printed parts in its rover exploration vehicle. There's a company called Made in Space that is developing processes and systems for making products in space, making them in the International Space Station to save rockets. In other words, something goes wrong, you don't have to incur the expense of a rocket to send up whatever is needed. You make it right there in space. And the photo here is, shows a zero gravity test of 3D printing. This is the Irby. The Irby is the first 3D printed vehicle. And the body of the vehicle has been 3D printed. they're working on printing the interior, the engine, and the drivetrain, and they have 3D printed tires, but the engine and drivetrain are not 3D printed. But there is, and this vehicle may be in production within about a year. It takes a while to 3D print it. That's a problem with it right now. But there was an open source effort to create an armored vehicle to replace the the vehicle that they use in war zones now. It's kind of like the replacement for the Jeep. I forget what they're called exactly, but it's like a Humvee or something like that. There was an open source challenge to create a 3D vehicle, and it was done by an open source community in 3 months. The entire vehicle, designed in an open source way, 3D printed. I mentioned that Ford has been using 3D printing for years, and BMW, for example, has used 3D printing techniques to develop tools that weigh less. So the people who are on the line, who work with tools all the time, they have less fatigue, less stress, because the tools that they're working with weigh less. So the techniques are being used not only to create products that are going to be sold, but products that help to make the products that are being made by companies like BMW. 3D printing in defense. And this is a picture of a rapid prototyping unit that is used on the front lines in Afghanistan. And an example of a 3D printed item that's has saved our government, money, is a gun sight for a tank, which used to cost over $100,000 each. By 3D printing them, the cost has come down to less than $40,000. And this is fascinating. The Army Corps of Engineers creates 3D models on the fly in disaster situations. So for example, during Hurricane Katrina, when New Orleans was almost destroyed, they made 3D models on the fly, one every few hours, of the topography of the New Orleans area so they could see where the water would go. This is something that the Army Corps of Engineers is doing. The future of war is 3D printing of drones, 3D printing of replacement parts on the battlefield, 3D printing of ammunition on the battlefield. But 3D printing in healthcare is, I think, something that may affect people's lives the soonest. Will have the greatest effect the soonest. Walter Reed Army Medical Center has 3D printed some titanium plates that they have put into various people's heads if needed them. There was a 3D printed jaw implanted in an 83-year-old woman in 2011. And just last week, I heard that 75% of a man's skull was replaced with a skull that had been 3D printed. I'll talk more about 3D printing in healthcare when we talk about one of the companies that's in the industry. Emma was born with arms that she could not raise. But by 3D printing artificial arms, she's now able to use her arms in a normal way, and those 3D printed arms can be reprinted as she grows. Other examples of 3D printing in healthcare. Wake Forest Institute for Regenerative Medicine has created ears, fingers, and in the upper left of that photo is a kidney that they're working on. There's also other companies working on kidneys. When I first heard about 3D printing, it was a YouTube video that someone sent me. And it was someone put a crescent wrench into a copying machine, and another crescent wrench came out the side. And I thought, this has got to be fake. This can't really be real. So I sent it to several friends, and I said, if this is real, it's going to change everything. And my friend Michael, who works for Johns Hopkins University Hospital, responded to me, and he said that the researchers here are working on 3D printing organs. He said it's still a ways to go, but they're working on it. A company called 3D Systems, which is one of the big players, we'll talk about them a little bit, they are doing custom coverings for artificial limbs. And of course, there are companies that are doing the artificial limbs too. If you lose a leg, you can have another leg made that looks just like the one that you lost. And there are several companies who are custom 3D printing hearing aids, and that's something that you will be able to do yourself very soon. Need a hearing aid? Download the parameters for it, print it, put them in. Now, I promised some sex. Just last week, and now that I've gotten interested in this, people send me emails all the time with the stuff that they see that's been 3D printed. And just last week I found out that Dita Von Teese unveiled the first fully articulated 3D printed dress. This was 3D printed, with a dress that is. If you could 3D print other things there, then we'd be selling a whole lot more of them a lot faster, like the bracelet or the speakers. And this was done in connection with Shapeways. I'll tell you about what Shapeways is in a few minutes. Now, 3D printing at home. Consumer Electronics Show in January of 2013, 3D printed things and 3D printers were all the rage. They were the big product. Anyone with a digital design can bypass traditional manufacturing methods and make it yourself. The Microsoft Kinect. Does anybody have a Microsoft Kinect? See one? Duncan has one. It's a device where you can you can play tennis in your living room, and so there's a game up on the screen. You'd see the tennis game, and you just move your hands around like this, so it's like a tennis racket, and the 3D Kinect camera sees that, and it translates that into your game movements. Well, there's a company in Spain that has adapted the Microsoft Kinect to be a 3D scanner. They've written software that allows you to use that to scan anything you want to scan. You can go around your house, go crazy, start scanning everything, convert that into a 3D file, 3D printing file, and then buy your printer and print it out. What's interesting is that the results that you get from 3D printers, and I'm going to pass around. This is my head that I had 3D scanned in New York a couple weeks ago and printed out, and then there's just a little nut and bolt here. The quality isn't great. Just pass it around. The quality isn't great, but there's this concept called good enough technology. People, early adopters especially, they're perfectly happy that it's not great, but they're willing to play with it, see what they can do with it, and then things get better, and products get better, and eventually it's really great technology. Right now it's good enough. There are uses being made in unexpected places. There's a school in Minnesota where an industrial design teacher is using it to show students what their designs look like. And I heard that there was some place in Australia where there was a 3D printing lab in a library. I didn't know where it was, but we were at dinner at some friend's house on Wednesday night, and I learned from his 22-year-old daughter that it's here. It's in Brisbane. It's in some library here in Brisbane, where there's a 3D printing lab. So people can go there, and they can learn about the technology, and they can think about what they might do with it. Then there's the open source community. And Robin talked about collaboration plus innovation. That's what the open source community is. And you've heard probably about open source software, but open source is a much broader term. And Wikipedia, for example, is an open source or an open platform dictionary or an encyclopedia. And it has put Encyclopedia Britannica out of business. It's made it irrelevant. Encyclopedia Britannica is a closed platform. Wikipedia is an open platform. Wikipedia is the future. And 3D printing has the same potential for any closed system. Think about that. Patents are closed systems. Copyrights are closed systems. Trademarks are closed systems. 3D printing has the potential to make closed systems obsolete. There's the RepRap. I think Lenny, a woman who's working on this organizing of the conference, she told me that her husband is making himself a 3D printer. And I said, well, it must be a RepRap. The RepRap is a 3D printer that was designed specifically to make more 3D printers. It is a self-replicating machine. You can get one for $500. There are over 20,000 of them in the world that are known, and her husband's going to have 20,001. So think Terminator 3, Rise of the Machines. Hopefully they won't become self-aware. At least not in our lifetime. There is a vibrant open community now that shares designs openly and freely. Toys I think we can forget about patent protection and copyright protection for toys, because everyone will start scanning them and then sharing the designs for them, just like on Napster and music file sharing, and they'll just start printing them at home. And why buy toys? Jay Leno, I don't know if you know who Jay Leno is. He's a famous comedian. He's a talk show host in the United States. He has a lot of money and an incredible antique car collection. And what he does is he's kind of a spokesperson for 3D printing, because he is creating parts, replacement parts for his cars that he can't buy. He can't get them anymore. And I was talking about this with my friend Bob last week, and he said he'd like to buy an antique Indian motorcycle. If you buy one with a headlight, it costs over $20,000. But if you buy one without a headlight, it costs a whole lot less, maybe $5,000 or $6,000. So if you can buy one without a headlight and then make your own headlight, you save a lot of money. Thingiverse is an online community for sharing 3D images freely. There are 36,000 designs available online now. They range from art to jewelry, to shoes, to gadgets, cell phone covers. If you need a switch plate for a very strange configuration of switches in your house, well, they're all there. You can download it, print what you need. There's also Shapeways. Shapeways was involved with the Dita Von Teese dress that I showed you earlier. And this is an online community and marketplace. So if you make designs and you want to sell them, this is where you can sell them. And there are over 7,000 what we call shops, 7,000 different merchants who are making and selling designs on Shapeways. Now, I put IP rights here, question mark. Well, the people who put this stuff onto Shapeways, they don't care about IP rights. They just want to sell their products. So, from their perspective, they don't care about protecting IP rights of their own. But by the same token, there are a lot of products, and there will be a lot of products that won't have, someone else might have copyright protection or intellectual property protection, but they'll all get posted on there and nobody will care about that. And right now we have 36,000 designs, and that's just the beginning. Just the beginning. Very new. Hardly anybody knows about it. Imagine once people do know about it, it becomes commonplace. You can buy your own 3D printer for $400, printer bot, or you can buy a Replicator 2, which was revealed at the Consumer Electronics Show in January. This was the Replicator 2. They had one before this. It was a little bit more primitive. This is the one that made my head in New York. MakerBot. I'm wearing my MakerBot t-shirt tonight. They have a retail store in New York where you can go in and have your head scanned and have it printed out in a variety of colors. So, the main feedstock, as I said, is ABS plastic. And this stuff isn't expensive, but you probably have a fair amount of plastic in your house that you have to throw away or recycle. You have soda bottles, you have clamshells from products that you bought. Well, this company, Filabot, put all this stuff in there and it turns into filament, and you use that filament in your 3D printer. So you can make use of all this plastic that you normally throw away or recycle. Why will it change everything? First, let's talk about the micro level. On the micro level, one machine makes everything. One machine makes everything. No retooling and no assembly. It's made in one piece. It can be made in one piece. You can make designs that can't be made in any other way, or traditionally, I should say. Interior structures that can't easily be manufactured now, like honeycomb structures for support. Rather than having a solid dense material, you would have a honeycomb structure inside. Well, that can just be printed. It's hard to do now. You can have lighter, stronger, more flexible items, fewer steps to manufacture. And it doesn't matter how complex the design is, complexity doesn't cost any more. Complexity is free. And you can make one of something on demand, and it doesn't cost you any more than if you wanted to make a zillion. Very efficient use of raw materials. As we showed in the video, there's no waste. And up to 50% less energy is involved. And if you combine that with low energy, like in the US now, we're going to be energy independent by 2035, and we'll be a net exporter of energy by 2020. And because of fracking, we have lower cost oil, and natural gas costs almost nothing. You combine that with 3D printing, and you can repatriate jobs, or keep jobs at home. And there's also less energy involved because there may not be any shipping involved. Make it where it's needed. Why it will change everything on the macro level? It has the potential to disrupt or destroy traditional models of manufacturing, distribution, warehousing, retailing. Future sales will be of designs, not of products. You will print them where they are needed, as I said before. So I think this will make the world smaller. Digital revolution made the world larger. I think this will make the world smaller because you will print things where you need them and you can do it just in time. And as I said before, you can print things at home. You could have a service bureau nearby that prints things for you. Or there may be companies that print things and they still ship them, and maybe shipping long distance or maybe locally. I think this will bring a lot more businesses local, be a lot more small businesses, allows everybody to become a designer, allows everyone to become a manufacturer, low entry barriers. Now this art that I found on the internet says 3D printing is killing manufacturing, and I think that is true in some sense. Think of the horse. You know, before the automobile, you had people who made saddles, you had blacksmiths, you had people who made buggy whips, you had people who built wagons and the wheels for wagons, and all of those people lost their jobs. But when the automobile came along, there were a whole lot more jobs. The same thing I think can happen with 3D printing. It will put companies out of business.